welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Arabic College, University of Delhi. So let me welcome you to this next lecture, or I can say to the second lecture of this Splay Trees, which is a topic under our Advanced Data Structures and Algorithm series. In the first lecture, we have covered what actually Splay Trees is, what are the scenarios where these trees or this data structure should be used, should not be used, both. What are the different types of operations which we are going to cover with which are supported by these Splay trees, and we have also looked into an extended operation. We try to understand the we can say what all kind of rotations are there, and we have also kind of named them. So when I am saying Splay trees, that means the operation of splaying is an extended operation which is supported by this. So splaying is actually a rotation. Now what kind of rotation I am talking about? So the rotations which are used in an Splay tree are either a zig or a zig-zag rotation or a zag rotation. So a zig rotation is used to bring a node to the root, while a zig-zag rotation is used to balance the tree after multiple access to elements in the same subtree. So if it is a single zig rotation, we are bringing a node to the root. If it is a zig-zag rotation, that means we are actually balancing the tree after multiple accesses to the elements in the same subtree. So first of all, let us try to understand these terms separately. So first is kind of a zig rotation. So zig rotation is if a node has a right child, we need to perform right rotation to bring it to the root, and if it has a left child, we need to perform a left rotation. Now what is that? Let us try to understand this zig rotation with the help of an example soon. So if we say zig rotation, in zig rotation in Splay trees, when we compare this Splay trees with the help of compare these Splay trees with AVL trees. So zig rotation in Splay trees operates in a manner similar to the single right rotation in AVL trees. So this rotation results in nodes moving one position to the right from their current location. And next, the term which I was talking about, zig-zag rotation, that I will be covering in a moment. So first let us look into the example of this zig rotation. So here if you can see, a figure is given on the screen. So here I am going to Splay 4. So Splay 4, when I am saying, that means I am going to perform a splaying operation, which is nothing but a rotation operation on this node which is having element 4, and after this rotation you can see that 4 is not now the new root of the tree. So 4 has taken the position of 6, which was the root earlier, and yes, we need not to kind of disturb the preservance of we need not to disturb the order of the nodes. So on the left side of 4 it is 3, on the right side of 4 it is 6, and again on the left side of 6 it is 5, and the right side it is 7. So this is just a single rotation, and hence it is known as zig rotation. So in this zig rotation you can compare this with the single right rotation in your AVL tree, and you will immediately find the similarities, we can say. Now I have given you in the previous lecture that there are 6 kinds of rotation: zig, zag, zigzag, zag-zig, zig-zig and zag-zag. So first of all, let us understand the single rotations, and then we will be looking into double rotations as well. So zag rotation, when I am talking about in Splay trees, it operates in a similar fashion to the single left rotation in AVL trees. So zig is kind of a parallel to say, or we can say similar to the right rotation of avial trees, while zag is similar to the left rotation of avial trees. So during this rotation, what is being happening is the nodes shift one position to the left from their current location. And what kind of example we can have here? So we have that tree which is having 4 as the root and 6 as its right child. And if we want to perform this rotation on the node having element 6, here we call that rotation as splay. So this splay 6, when we perform on this tree which is given on the left side, which is nothing but a single left rotation. So 6 is going to be the new root node of the tree, because now a left rotation is being performed. So, and in order to preserve the we can say order of the nodes, because we need not to, or we are not even allowed to disturb the search properties of binary search tree. So 6 is having 7 as the right child, while 4 as its left child. On the right of 4 it is 5, and on the right of 3 on the right left of 4 it is 3. In this way we have seen zig rotation and zag rotation. An example of both we have seen. So zig rotation is parallel to the single right rotation of abial trees, while the zag rotation of splay trees is equivalent to single left rotation. Now moving further, the remaining 4 kind of rotations are not single rotations, they are double rotations. Either they are left performed after right, or right performed after left. Obviously the terminology used here is zigzag. So let us move on to the next one. So the third kind of rotation is zig-zig rotation. So it is a double zig rotation, we can say. One zig position is shifting the node to we can say to one right position, and double zig rotation results in nodes shifting 2 position to the right from their current location. So let us see this with the help of an example. So here we are splaying 3, which is you can observe is the leftmost node of the tree. The parent node of this 3 is 4, while for 4 the parent node is 6. So we will performing double right rotation. So in one right rotation it will become the node 3 will take the position of 4, and in the second right rotation it will take the we can say position of as position of the root node. So now after double right rotation or after zig-zag rotation, so first step takes 3 one level up in the right direction. The second level or the second rotation is going to take 3 up on the right direction. So now 3 is at the root node. In order to preserve the nodes or in order to preserve the order of the nodes, 4 has become the right child of 3, 6 has become the right child of 4, while 5 and 7 are the left and right child of 6. Now you can also see the changes or effects in terms of change in height. That is also be kind of taken care after some rotations, we need to say. Now moving on to the next rotation, which is zigzag rotation. So zigzag rotation, if we talk about in splay trees, the zigzag rotation obviously is a double zag rotation. This rotation causes the nodes to move 2 position to the left from their present position, and obviously one level up in each position, because the basic agenda is to keep that node closer to the root node, or even making it the root node. So, for example, if we look into double zag rotation, so here is a double zag rotation which is performed on the node 7. So, that is why we have named it as Splay 7. So, it is a double left rotation. So, in one or in the first zag rotation, 7 will take the position of 6. Obviously, the order of the nodes is to be preserved, and in the second zag rotation, this is going to take the position of 4. So, now if you can see 7 is on the root node, to the left of that it is having 6, then to the left of 6 it is 4, and 3 and 5 are the left and right child of 4. And also please notice the change in height when we are performing double rotations. So, in case of zigzag rotation, we have also seen one change in size or height, or in effect of these rotations on the height of the tree. Similarly, in zigzag rotation, which is the double left rotation, we have also seen that effect on the height as well. Moving on to the next one. So, till this point we have covered in terms of single, we have covered zig rotation, zag rotation, which are right rotation and left rotation, then zigzag, which is double right, and zigzag, which is double left. So, what if it is one left followed by right, or vice versa, which is right followed by left. So, first let us look into this, which is zigzag rotation. So, zigzag rotation, as the name suggests, is basically a combination of zig rotation followed by a zag rotation. So, a combination of left and right. As a result of this rotation, the node shifts one position to the right and then one position to the left from their current location. Now, what do I mean by that? I am repeating the sentence, that as a result of this zigzag rotation, the nodes shift one position to the right because of this zig rotation, again followed by zag rotation, that means shifting one position to the left from their current location. So, let us see. So, here the tree which is available on the left side of the screen. So, we have 4, 3 and 6 as its left and right child, and 5 and 7 as the left and right child of 6 respectively. Now, if we are going to say Splay 5, so that means Splay 5 here, that means with the help of a, or we are going to perform a zigzag rotation. So, when we are performing a zig rotation on this, so we are going to have the tree which is shown in the middle, which says that 4, 3 is the left child. Now, 5 has taken over the position of 6, and because of preservance of order, because it is a search tree, we cannot compromise the preservance of order. 6 is the right child of 5, while 7 is the right child of 6. So, this was just one zig rotation in which you have performed you have performed Splay 5, and 5 has come up one position up, one position right. Now, let us say moving on further, we need to perform zag rotation. Now, if we need to perform the zag rotation, so zag rotation says coming to the left thing. So, here this 5, so zag rotation is performed on 4. On the basis of this zag rotation, or because of this zag rotation, your root node is 5 now, with 4 and 6 as its left and right child respectively, while 3 is the left child of 4 and 7 is the left child of 6. So, if you can see, when we are going to perform Splay 5, we are going to perform one right rotation and then one left rotation, which is zig and zag, and hence we have got the tree which is shown on the right side of the screen. And also please notice whether there is a change in the height or not. So, as far as the whole tree is concerned, not the individual nodes, I do not find any change in this particular for this particular example only, although we cannot guarantee the same for all. Now, here it was a zig rotation followed by a zag rotation. Coming to its kind of reverse order, which is a zag zig rotation. Zag zig rotation in Splay trees is a series of zag rotations followed by a zig rotation, and this results in the nodes moving one position to the left followed by shift one position to the right from their current location. Now, also we will understand this with the help of example. So, here we have a tree which is having 6 as its root node, 4 and 7 are left and right child respectively. Now, for 4, 3 and 5 are the left and right child, and we are doing this zag zig rotation on 5, which is we commonly known as Splay 5. So, when we are coming to after one zig rotation, the situation after one zag rotation, the situation is 5 has occupied the position of 4, 4 has become the left child of 5, while 3 was already a left child of 4, hence the order is also preserved. And after this zag rotation, we need to perform a zig rotation also. Because of that zig rotation, this 5, the element 5 is going to take the position of 6, and 5 obviously is having 6 as its right child, while 4 as its left child, followed by 3 as the left child of 4 also. So, this were the two examples of zag zig rotation and zigzag rotation. So, till this point we have covered all the 6 rotations, which are zig zag, then zag zag, zig zig, zag zig and zig jag. All the rotations we have covered. Now, let us talk about in the inception of this topic of Splay trees, I have told you that whenever we are performing insertion, also whenever we are performing search operation, not obviously in case of deletion, the insertion operation when we talk about in Splay trees, it is performed in the same exact way as we used to perform the insertion in binary search tree. But after this insertion, the splaying thing has to be performed. So, the procedure to perform the insertion in the Splay trees in a comprehensive manner will be, we need to check whether the tree is empty, and if the tree is empty, we need to add the new node, and then we simply exit, because that is the only node which is being inserted, that is the only node which is being accessed, and that is the only node which is obviously on the root also. So, we need not to do anything. So, for example, we are inserting 2 elements one at a time, and these elements are 1 and 3, and we need to insert them into the Splay tree. So, 1 we have inserted, we need not to do anything. As far as 3 is concerned, if we want to insert 3, the same procedure will be followed as we did in our binary search tree. That means 3 is compared with 1, then its position will be determined, that this will go on the right side obviously on the leaf. The only node available is the root node. So, we are going to insert 3 as the right child of this node 1. So, if the tree is not no, this is the situation where the tree is not empty, and we are adding a new node to the existing tree, and the process is obviously of the binary search insertion. So, when we add 3 to these Splay trees, the situation will be something of this sort, which is shown on the screen. So, 1 as the root node and 3 as its right child. Moving further, is it done with the is it done for the insertion of Splay trees? No, because the recently accessed node is 3. Now, as far as splaying is concerned, we need to keep, or we need to bring this 3 onto the root of the Splay tree, and for that we need to perform the splay operation, and because of that splay operation, which is equivalent to the left kind of, we can say, left rotation of the avial tree, which is zag rotation here in Splay tree, we are performing this on 3, and hence we are going to have this tree as the resultant tree. So, with the help of this example, we have established that it is not only the insertion of the binary search tree, but in case of Splay trees, it is the insertion procedure of the binary search tree plus splaying given as an extended operation. So, if we talk about drawbacks of Splay trees, we have also seen them in our earlier lectures. We can talk about memory usage because a lot of memory is required. Each node contains additional information, high time complexity for the even for the basic operations, because insertion and this searching requires these to be reorganized every time. This reorganization itself carries some overhead, and there are limited use cases because they cannot be used in each and every applications. So, normal applications in which we can use Splay trees are like caching, database indexing. I have already told you about data compressions, file systems, and so on, and so forth. So, here in this lecture we have seen all the 6 types of rotations with the help of examples, and we have also seen that how a complete insertion process is going to take place in case of Splay trees, which is insertion plus splaying. And here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this lecture. I will see you in the next one. Till then, take care. Goodbye.